Okay, good afternoon, all. Let's continue with the discussion of various operations on single linked list. Before I proceed, guys, I had given you an assignment in the previous class. If you can remember, it was creation of an ordered list. Okay, has anyone tried it? Has anyone got it? Please share the things that you have tried from your end. Has anyone tried? Yes, please let me know. Okay, Praveen has commented yes. What about others? Has anyone tried? Okay, Srinivas has commented yes. Yogesh has commented yes. Ananya. Okay. Anyone has got the proper kind of output for it? I will just wait for a while, okay, for your answers. Please comment quickly. Yes, Praveen, can you just go ahead and explaining the things, or else I'll call Ananya. Can you unmute and explain? Ananya, you're there? Yes. Can you share the screen of yours? Yes. I'll be waiting for that. Okay. Yes, scroll down, Ananya. Just scroll down. These all are mandatory. Correct? Yes. Scroll down. Insert rare. That's fine. That's fine. Okay. Yes, can you explain this part? You can unmute and please try explaining this part in short. I'll unmute from your end. Ananya, I'm unable to hear your voice.
Now you can hear me, ma'am.
Yes, now I can hear you. Please go ahead.
First, I've created a temporary node, ma'am.
Okay.
And here, if it is an empty list, so I have returned the temporary node.
Okay, I call it as base condition.
Yes, ma'am.
Okay.
So here, if the first element itself is greater than the one which we are inserting, ma'am.
Yes.
So for that, I have given this condition.
It means you are adding the new node previous to the first node.
First node, yes, ma'am. So I
And
am
first
reinitializing
node
the first
changes
one.
to temporary node. Okay, next.
Next, here I have taken the current, ma'am, current
Yeah.
and previous and the
Yeah.
while loop,
Huh?
and I have checked until the element is less than or equal to the one which we are inserting.
Correct.
So if all the elements are less than or equal to the inserting element, then we'll insert the new element at the end of the list.
Correct.
Otherwise, we will
Insert in
insert it
between.
in between
In between. Yes.
previous and current.
Yes, you are right. You are right. So can you run this code and show? Good try, Ananya. Okay, start inserting. Give 23. Insert again. Give 12. Now display. Yes, it is working. Now insert again. Insert 15, 1, 5. Display. Working good. Insert again. 25. Display. Yeah, 3 is the choice.
Yes,
Yes.
ma'am. For display.
I think I'm unable to, yeah, I'm sorry. 12, 15. Yeah, it is correct. Okay, you can end sharing. Thank you, Ananya, and it's a very good try. Please click on stop sharing. Go back to your Cisco WebEx and click on stop sharing. Yeah, thank you. Is there anyone who has tried this? Praveen, you're there? You had typed yes. And Srinivas? Srinivas, you're there? Srinivas Dikshit. Okay, can you share the trial that you have done? It may be in your piece of paper, it may be in your book, it may be in the computer, whatever it is. Okay, fine. How about Praveen?
Yes, ma'am.
Yes, it's working.
Yes, ma'am.
Can you share it?
Yes, ma'am.
Quickly do it. Don't waste time. Quickly do it.
Is it showing, ma'am?
Just one. Yeah, it's visible. Can you just explain the part of the code which is for inserting at a proper position? Okay, leaving the
This
base
is,
condition.
yes, ma'am. After this,
Yes.
ma'am,
Uh,
this one is a condition for only one element, ma'am.
okay.
It will check if the element to be inserted is less than the first element, ma'am, first input, ma'am.
Okay. Yeah, yeah.
So, so
You go
it
to
is
else
just,
part. Else part you go. I
okay, ma'am.
want the else part. Okay.
Yes, ma'am.
Just
This,
prompt.
ma'am. So
Hmm.
it is checking, ma'am.
Hmm.
It will check up to the last position, ma'am. If the
Hmm.
element to be inserted is less than the current element, ma'am, It will check
Okay.
whether it is the first element, ma'am.
Okay, 1 minute,
If the
Praveen.
element is at
Probably this if condition is not required because you might have checked it in the previous if else. There only you have covered it.
no, ma'am. No, ma'am.
Okay.
No, ma'am. It was sorry, ma'am. It was like, ma'am, if
Huh?
only one element was there, ma'am, it
Hmm?
will just check, ma'am, whether it is less than. It will assign it before that, ma'am, and if it is greater, it will attach it after that, ma'am. But in
Okay.
this condition, ma'am, in this loop,
Hmm?
ma'am,
Hmm?
it will if if there are many elements, ma'am, if there are more than one element, ma'am, it will check
Definitely,
from
but in
first.
any case, if the element is lesser, okay. Okay, you have written a generalized statement. Fine, fine.
Yes, ma'am. So
Okay.
if there are more than one element, ma'am,
Yeah.
so the first will not be having the null part, ma'am, as the
Yeah.
link.
Yeah.
So it will come to this condition, ma'am, and it
Okay.
will check, ma'am.
Yeah.
Now, at starting, ma'am, current will be first, ma'am. It will check whether it is less than the current first part, ma'am, because
Okay.
for the first part we have to do something else, ma'am. We
Okay.
don't have any previous part for the first, ma'am. So I have
Okay.
done this if condition, ma'am, like copying the first into a temporary variable, uh, and then linking the first to the current, ma'am, because current is now directing to the first part. Now return first, ma'am.
The inner else is for the in between insertion, correct?
Yes, ma'am. Yes, ma'am.
Okay.
So
Yeah.
the previous will link to the temporary part, ma'am, which is having the new node, ma'am, and that temp will link to the current, ma'am,
Fine.
the next part, ma'am. So it will be previous temp and that current, ma'am. They will be linked together, ma'am, and I will return the first, ma'am.
Yes.
Now
You can
after
stop
that, ma'am,
sharing, Ravi.
okay, ma'am. How to do it? Like that.
Okay, in any of the
Ma'am,
functions that is being shown, Praveen, I will just
how
comment
to
it like
stop
this.
sharing?
You are not able to stop sharing? Stop
Sorry,
sharing?
ma'am, I don't know, ma'am.
Hare, you just go back to Cisco WebEx,
Okay, ma'am.
go back to Cisco WebEx, and there will be option called stop share. Unable to do?
I will do. I will do, ma'am. Sorry,
Otherwise, I'll
sorry.
do it. Don't worry.
Sorry, ma'am.
You are unable to do? Then I will do it. Don't worry.
No, ma'am. Please do, ma'am. Please,
Okay,
sorry.
I'm doing it. Yes, now it's gone.
Thank you, ma'am.
Okay,
Thank you, ma'am.
yeah. Now, just 1 minute. Okay, in any of the functions that are being explained by your friends, what is very common is the first thing that you are doing is the base condition, whether first is none. Okay, so that is the first ever condition for any kind of insertion that you take up. So first equal to null, that is the first condition. Second condition talks about whether you want to insert from the front end of the list. It is based on the value that you are inserting. Based on the value that you are inserting, the position fixes whether the position into which the new element is getting into, is it at the front of the list. This is second condition. Okay, then third I will talk about whether the new element that is entering in, whether it is taking the last position of the linked list right now available. Okay, this is the third condition. And the last option that is available is in between insertion. So in any kind of these things which you are doing, it talks about insertion at the front of the list, insertion at the rear end of the list, or insert in between, or if you are inserting for the first time, the first ever element will become the new first element of the linked list. Okay, before I proceed, I also want to show you my code for you. Okay, there is some comment by Anushka. Can I use sort function without doing all these things? Can we use sort function? Definitely you can use the sort function. Okay, um, okay, it means what? You are inserting as and when the element comes in according to the rear end or front end insertion, as we have done previously. Then call the sort function. It's one and the same. Nothing wrong in doing that. Anushka, I think I have answered your question. Okay. Now I'll be sharing the screen
and I'll be showing you the part of the code that I have written. Okay, so let me just go to the GDB compiler. Okay, 1 minute. Just give me time because I'm just I have tried many other programs. Okay. I just go to my projects and just open the program which is called as ordered list. Okay. For simple insertion, I have also taken insert rare. Okay. Just have a look at it. I have used a create node function. This remains the same. And when I'm trying to insert the elements, I have taken this. Okay. Let me just go through the function line by line. Okay. So first thing that I have done in these 3 lines of code, what I have done. Can anybody quickly comment what is capital NODE indicating, so that I just want to know from your end whether you are remembering the previously discussed things. What is capital NODE? Okay, it is struct node start. Thank you all. Now, with reference to that, a new node is getting created and that is pointed by a pointer called temp. Okay. Now, temporary nodes info part I am filling up with the new element that is coming in. And these 3 lines of code, they remain common for any insert function that you take. You create a node, fill the element that you are trying to insert in the info part, and fill the link part of the newly created node as null for simplicity. Okay. Then this is called as a base condition. It is called as base condition. In any of the insert function, this condition holds good when there are no nodes in the linked list. When there are no nodes, I will simply print inserting the first ever node in the linked list and I will return the temp. Or otherwise, you can assign first is equal to temp as told by Praveen in the previous class. Okay. Now, other than this, what all are the different conditions that are available? Base condition talks about I am trying to insert the first ever node in the linked list. This is done. Next remaining conditions are there are if you want to insert the element, you want to insert it to the front end of the list. This is first condition. Second condition talks about I want to insert it at the rear end of the list. It means what? The largest element is coming into picture. And when I want to insert at the front end of the list, in the ordered list, the element that I am trying to insert right now, it is the smallest element available that will be made available in the linked list. So insert either the smallest element at the front of the list, insert the largest element at the rear end of the list, or insert the element according to its position in between the linked list. So 3 conditions I have to bother about. How do I bother about these things? Simple condition that I will add is the element that is getting inserted, whether that element is lesser than the info part of the first ever element that is right now available. So you just imagine like this. Draw a picture in front of you, please, all of you. What you imagine is there are elements like this. 12-23. So what is the meaning of that? 12 is right now the new element that is getting inserted. Sorry, 12 is the first node of the linked list right now. And 23 is the last node of the linked list. Right now you have exactly 2 nodes in the linked list. You just imagine like this. 12 at the initial node, that is first is pointing to 12, and 23 is the next element which is the last element. This is right now available. Now if the new element getting inserted is 10, you just imagine 10 is the new element to be inserted. Can you please, could you do me a favor, okay, by drawing this diagram in front of you? What you do, you draw 2 nodes. First node pointed by first contains 12 as the element. The link part of it is linking to one more node, that is 23 followed by a null. Okay. Now At this point, I want to insert one more element by the info part 10. So what is the position of 10 according to you? Can you comment quickly? At what position or where the 10 has to be inserted? At the first, at the beginning. So I'm talking about the first condition here, whether the element to be inserted is getting inserted at the front end of the list. So how can I do that? It's very simple. How do you check that condition? The element that is getting inserted is lesser than current first node's info part. Current first node's info part. That's it. Okay. This is the condition to check whether the element to be inserted is lesser than the first node. If so, what should I do? I will do this. So definitely temporary node would have got the element 10. Now I want to insert 10. Temporary node has got 10 and a null. So what I am supposed to overwrite? I am supposed to overwrite temp arrow link to the current first. And I am going to overwrite the first for the next iteration. How do I do that? I will return the address of temp, and in receiving, in the main, receiving, when I am receiving, it is receiving, the variable that is receiving is first. So first getting overwritten with the address of temp, which is the new element that is inserted. So my first condition is done other than the base condition. Other than the first thing that I am writing is base condition. Then I am talking about whether the element to be inserted is less than the first arrow info. Then the else part. This talks about two subconditions in it. Okay. Whenever you want to insert any node in between, definitely I require two pointers, previous and current. Current will be pointed by the current node, and I require previous because the previous node's link has to be changed. So two pointers I have taken as we had discussed in the previous example. Please note the same thing I have taken. Previous is equal to null, current is equal to first. So you just imagine like this. All of you draw in front of you. Always for this whole chapter, have a piece of paper and pen in front of you. Only then you will understand it. Okay, you just imagine that. Now, the current linked list contains 10, 12, 23. 10, 12 and 23. Okay. At this point, I want to insert 25. What is a new node that is getting inserted? 25. According to you, where 25 gets inserted? Fatafat comments I need. Last. What about others? Where 25 needs to be inserted? Last node, correct? All of you note it very clearly. 25 has to be inserted as the last node. Okay. You just imagine that I want to insert 15. Where 15 has to be inserted if 15 is the new node? It is third, that is in between. Okay. So in this else part, I am taking care of both these conditions. Right now, you just imagine the element to be inserted is 25, which needs to be inserted at the rear end. Okay. So what is that I am supposed to do when I have to reach the last node of the linked list? Simple thing that I will be doing. Current not equal to null. While current not equal to null, current is equal to current arrow link. Okay. I'll be moving the current until it reaches the last node. Now what I want, along with the movement of current beyond the last node, current has to move beyond the last node. When I want to move the current beyond the last node, I will write current not equal to null. If I write current arrow link not equal to null, current will be pointing to the last node. But what I want current to move beyond the last node, because until I cover all the nodes, this loop has to continue. So who will hold the address of the last node? Previous. Okay, let's go ahead with this while loop. Until current not equal to null, until all the nodes are visited. If at any point in time, element that I am inserting right now has become lesser than the current arrow info, please do this in front of you, which is which is in front of you, please do it thoroughly. Okay, I have shown you 10, 23, okay, 10, sorry, 10, 12, 23. This is the existing linked list. Now the element to be inserted is 25. Okay, with this background, let's go ahead. Element to be inserted is 25. Current, from where it will begin? Current will begin from 10. All of you have to have that diagram either in your brain or in the paper that is there in front of you. Then try analyzing this. Please do it parallelly. So right now, current and first both are pointing to 10. Who is the new node to be inserted? 25. Which is the new node to be inserted? 25. Okay. Now, current and first both are pointing to 10. Okay. Current, whether it is null? No. So it enters the loop. What is the element to be inserted? 25 is the element to be inserted. 25, whether it is lesser than current's info. What is current's info? 10 right now. 25, is it lesser than 10? No. It just goes to the if part. Anything outside the if, anything, these two are considered as else part. You need not write explicitly else. Okay, when you have only one statement associated with if. So previous is equal to current. What happens? Previous is equal to current. Where previous comes? Previous comes to 10. And current is equal to current arrow link. Current moves to 12. At this point, previous and first are pointing to 10. Current is pointing to 12. This goes back. Whether current is null? No. It enters the loop again. Element is 25. 25 less than. What is current arrow info? Can you quickly comment right now? What is current arrow info? 12 it is. Current arrow info is 12 because we are talking about 10, 12, 23 right now, the existing linked list. Okay. Now 25 less than 12 fails, comes to else part. Again previous gets incremented. Previous comes to 12. Current goes to 23. Okay. Previous is at 12. Current is at 23. Goes back. Whether current is null? Not yet. Current is not equal to null. So enters the loop again. 25 less than. What is current arrow info? What is current arrow info? At this point, it is 23. 25 less than 23 fails. So comes out of the if and goes into else. And what is there in else? Previous is equal to current. So where previous comes? Previous comes to 23. What about current? Current equal to current arrow link. It will be null. It will be null. So goes back. Null not equal to null fails. Comes out of the loop. At the end of this loop, either this loop breaks in between if the element is found lesser than any current node, or it will end the loop only when current and previous have reached the dead end of the linked list, in such a manner that current will be a null and previous will be pointing to the last node. Okay with this? Okay with this? Now assume that, when can I assume that I have reached the dead end of the list? What is the condition, or at what point the loop ends? When current becomes null, at that point the loop has ended. It means if the current is pointing to null, it means I have to insert the new element at the rear end of the list. So that condition only I will take. If current is equal to null, what is that I need to do? Previous will be holding the last node's address. So previous arrow link is equal to 10. If not, so for 25, current will be null. Previous is 23. 23 is a link I will attach to 25. Are you all okay with this explanation, or any doubt you have? I will take one more example which is in between insertion. Whether the rear end insertion is clear for you or not. Please comment quickly. Okay. So all of you have this picture in your mind right now. I have the elements 10, 12, 23, 25. I will repeat. I have 10, 12, 23 and 25. Where first will be pointing to 10. Now I have called this insert function again. Okay, I have called this insert function again with the value 15. What is the value that is getting inserted? 15, 1, 5. So element right now is 1, 5. Okay, element right now is 1, 5. So what happens? Temporary node gets created. What is the position of 1, 5? Third position. You have answered to this already. Info part of the temporary node is filled with 15 and temp arrow link will be null. A new node with the value 15 and a null as address part will be created. Whether first is null? No. Whether element is 15. Element is 15. 15 less than first info 10. 15 less than 10? No. Comes out. Where it goes? Into the else part. Previous has started from null. Current has started from first. Okay. Now, until current not equal to null. So what is current? Where current will be pointing? 10. The initial value. What is the element that is getting inserted? 15. 15 less than 10. No. So, increment previous and increment current. Previous comes to 10. Current comes to 12. Previous comes to 10. Current comes to 12. Goes back. Whether current is null? No. Element 15 less than 12. 15 less than 12. No. So, it goes into else part. Previous comes to 12. Current comes to 23. Previous is at 12, current is at 23. Goes back again. Current not equal to null, true. Enters. Element is 15 less than 23. 15 less than 23. Is it true or false? It's true. So what has to happen? It has to break out of the loop. It will come out of the loop. Okay. It has come out of the loop. Now what is there outside the loop? Whether current is null? No. It means what? I have to insert the new node in between. Okay. So it goes to the else part. Quickly tell me where is previous, where is current right now? To which element previous is there? To which element current is there? Okay, previous is at 12, current is at 23. Now the new element getting inserted is 15. So can anybody tell me what all are the things that I need to write in the code? I'm not shown it. I'm not shown it. Can you comment from your end what should I write the code? Over here. I have to insert the new node, temporary node between the previous and the current. So what should I write? Okay, Praveen has commented previous arrow link is equal to temp. Let me just see it. And temp arrow link is equal to current. Anyone else? Between 12 and 23, 15 has to come. So can anybody comment? What should be the code that I'm supposed to write? We are taking so much of time. Between previous and current, you have to include temp. So what should I write? 12 has to link to 15. 15 in turn has to link to 23. So I need to write, let me just show it. Previous arrow link is equal to temp. Temp arrow link is equal to current. And in any of these cases, whether the first node is getting altered? No. Either you are altering the last node or you are altering the in-between node. Okay. So, since my return type of the function is node, I have to write return first. Okay. So, this is the overall function for inserting the nodes in the linked list in the ordered manner. If I want you to change it to descending order linked list, what is the change that you are supposed to do? You can tell me the line number where I need to change. If I want, this is ascending priority queue, okay? If I want to have a descending priority or descending ordered list, so what should I change? Okay, in line number 48 and line number 59, I have to do, instead of less than, I have to write greater than. This is a comment by Praveen. What about others? Is it correct? Type yes if it is correct. Okay. So if I change it to greater than, element greater than, here as well as here, line number 59 and line number 48, it will be changed to descending ordered list. Okay. Probably I have 5 more minutes of time. Before we end this session, I will give you exactly 2 minutes of time. You just imagine that there are two linked lists parallelly available. First linked list pointed by the pointer first, second linked list pointed by second. Okay, you just imagine like this. First linked list has 10, 20, 30 as the elements. Could you please draw it in the paper that you have? First linked list has 10, 20, 30 and first is pointing to 10. Okay, and I have a second linked list having 40 and 50. Having 40 and 50. And 40 is pointed by a pointer second. Okay. Have you drawn it? If yes, please type yes. I have two linked lists. I have two linked lists 10, 20, 30 as the first linked list where 10 is pointed by first. 40 and 50 are in the second linked list where second pointer is pointing to 40. Now what I want is, I want you to have concatenation of two linked lists. It means what? In the single linked list, I want to have 10, 20, 30, 40. Can anybody tell me how I can do this? You have only 1 minute of time. You have only 1 minute of time for answering this. I have to combine it into a single linked list. How can I do that? I call it as concatenation of two lists. Yes, anybody can comment. See, there is no condition checking at all. It means I have to attach the second linked list to the first linked list, to the end of the first linked list. What is that I need to do? Okay, I'll just linking first node last link to second node first link. Correct. The last node of the first has to be attached to the first node of the second. Okay. Current arrow link is equal to second. What is current, Ananya? Afzal, what is current? Current is equal to first, ठीक है. How do you link it? Current arrow link is equal to second. Okay. So 30 arrow link is equal to second. You are right, Praveen. Okay. Can I will just write only those lines of code for you. Okay. See if I have a first and a second. Okay. So how do I do? I will just write current is equal to first. Okay. Then I'll write while current arrow link not equal to null. I'll write current is equal to current arrow link. So at the end of this while loop, current will be pointing to the last node of the first linked list. Already second is pointing to first node of second linked list. So what is that I am supposed to do? I will do simply this. Current will be at the end of this while loop. Current will be pointing to where? Can anybody comment quickly? At the end of this loop, where current will be pointing? You have 10, 20, 30. Correct. 30 is the point where the current will be pointing at the end of this at the end of this loop. Next, what I'm supposed to do? I'm just writing current arrow link equal to second. Second remains intact. And what I will do? I'll write return first. So the overall linked list will be now pointed by first. Now if I ask you, are you all okay with this explanation? Only this much you are supposed to do. If I ask you to concatenate first with the second. Is this clear? Comment yes if you have understood this. Only 3 yeses. Okay. Now if I ask you to have a concatenation of second with first, what is that you are going to change? I am left out with only 3 minutes of time. If I ask you to have, okay, if I ask you to have a concatenation of second list with the first one, what is that you are doing? Okay, wherever first is there, change it to second first. Okay, current is equal to second. It means current will be pointing to the first node of second and increment current until the last node of the second linked list. So at the end of this while loop, where current will be pointing, in this case, to which node it will be pointing? It will be pointing to 50. Okay. Now at the end of this, okay, you are right. All of you are right. Current arrow link is equal to, instead of second, I will write first. And instead of returning first, I'll return second, because second will be holding the address of the first ever node of the concatenated list. Are you all clear with this? Any doubt you have? So can I give one more assignment for you today? A trial, okay? You have a linked list available which is already created. You can use any of the ways of creation of the linked list by inserting in any mode. Insert where, insert front, insert in the ordered list, whichever that is done. In any manner, the created linked list is already available. You just imagine like that. The available linked list has to be reversed. It has to be reversed. It means the last node has to be the first node has to be the last node, and the links have to be arranged in that manner only. Okay, reverse a given linked list and print the reversed list. Can you try this for today? Can you try this? At least say okay. Okay, so that is the assignment for today. So we will end the class for now. If I use concatenate function, it will be good. Or concatenate function is not there, Anushka. Concat function is available only for strings. It's not there for linked list. Your question is valid, but concat function is not there. Okay. Can you please upload 12th and 13th November? I think Shreya, I have even I saw your message in the previous class also. Let me just check. According to me, I have uploaded it, or otherwise it has not been recorded. I'm so sorry for that, Shreya. I'll just check 12th and 13th November's according